There is a rectangular plane. This is dimension of the plane 30 mm by 60 mm. Has its shorter side in HP. So if you consider a rectangular plane 30 by 60 mm dimension, so it is going to have two shorter sides and two longer sides. Out of those two shorter sides, one of the side is located in HP, and the same side, the side which is in HP, it is inclined at 30 degree to VP. Draw its projections when the plane is inclined at 45 degree to HP. So the surface inclination is 45 degree to the HP. Now if you look at this statement, this plane is inclined to HP as well as VP. So when the plane is inclined to HP as well as VP simultaneously, that plane is called as an oblique plane. This one is called as an oblique plane. So now let's see how we define the position of oblique plane. We are saying that oblique plane is nothing but when it is inclined to HP and VP simultaneously. It is inclined to HP as well as VP. But that inclination will be provided in some kind of wording, and from that wording you need to identify the inclination of the plane with HP and VP. So usually when they define the position of oblique plane, it is defined in two forms. The first inclination is called as surface inclination, and second inclination that we can call other inclination. In that inclination, it could be inclination of the side, inclination of the edge, inclination of axis, inclination of diameter,
It's 11 hours.
inclination of diagonal, etc. It could be anything out of these. So when the inclination of plane is given, surface inclination and other inclination we need to identify. Now why do we need to identify, or why need to separate those inclination? Because we are saying that oblique plane is nothing but the plane which is inclined to HP as well as VP simultaneously. So it is obviously inclination of the surface with HP and VP. Then why we are splitting that inclination in terms of surface inclination and other inclination? That we are going to discuss further. But for time being, consider that the one of the inclination will be in the form of surface inclination, and other another inclination is going to be inclination of side, edge, axis, diagonal, diameter, etc. Okay. Now when you are going to solve the example based on the oblique plane, the solution is going to have three stages: stage number 1, stage number 2, and stage number 3. The first stage or first step is called as basic view. In second step we consider surface inclination, and in third step we consider other inclination. So the inclination that we were splitting into two, the first one surface inclination, and second one is other inclination. So the surface inclination is going to be considered in the second step, whereas the another inclination, that is going to be inclination of side, edge, axis, diagonal, diameter, etc., that is going to be considered in the step number 3. Now when you are going to draw a basic view, there are certain things that we need to identify, or we need to fix first. First, you need to identify surface inclination. Once you have identified surface inclination, whether that surface is inclined to HP or VP, to draw basic view, step number 1, we need to reduce that surface inclination to 0 degree. If surface is inclined to HP, we need to make it parallel to HP. If surface is inclined to VP, we need to make it parallel to VP. I'm talking about basic view. So when we are drawing basic view, we are going to reduce surface inclination to 0, and we are going to make that plane parallel to that reference plane, whichever it is inclined to. So that is the first thing. Second thing, find the resting reference. Find the resting reference, then keep that resting reference at left, and try to keep that resting reference perpendicular to xy. These two things we are supposed to do to draw a basic view. In second step, surface inclination, the inclination that you have reduced to 0 degree while drawing the basic view, that inclination we are going to provide at the step number 2. So here we are going to consider surface inclination, and in step number 3 we are going to consider the other inclination. Now when you are going to draw a solution, there are going to be two scenarios. Either first step of the solution you will get in top view, or first step of the solution you will get in a front view. Let's consider scenario 1 or scenario A. If you get first step in a top view, you will project it, draw a second step, then the view that you have obtained in the step number 2, exactly same view with same dimensions, same shape, we are going to draw in step number 3, but in a different orientation. So the view that you have obtained in the step number 2, that you are going to rotate to provide certain inclination with HP, and you will get the view number 3. So dimensions of 2 and 3 are same, nomenclature of 2 and 3 same. Then you will project the view 3. You will take projections from view 1, and you will draw view number 4 or step number 4. Now once you have got step number 4 and you are going to draw step number 5, similar relation exists in case of step number 2 and 3. So step number 4 and 5 going to have same shape, size, dimensions. You are just going to rotate that view, or you are going to change its orientation to make it inclined to vertical plane, whatever given inclination is there. So that is going to be step number 4. And last, step number 6, taking projection from step number 5 and step number 3, and in connecting intersection point, you will get the step number 6. So if you look at the flow, we are going to move in a zigzag path. Okay, so this is scenario 1. Let's say this is scenario 2, where you have got your first step in a front view. So you will project it, you will get a step number 2, step number 2. This is step number 3. Similar to first scenario, exactly same rules are applicable to both the scenarios. So view number 2, you are going to rotate or change its orientation to make it perpendicular to VP. In this scenario, this is surface inclination, so inclination with HP in step number 2, and this is other inclination, and this is inclination with vertical plane. Whereas in scenario B, where you have got the step number 1 in a front view, when you are going to draw a step number 3, this inclination is going to be inclination with vertical plane. You will project this view, you will take projections from step number 1, and you will get this step number 4. Now once you have got this step number 4 and you are drawing step number 5, similar to the scenario 1, you will rotate this view by keeping same dimensions, and in this case the inclination that you are going to provide, this inclination is going to be with HP. Then project it vertically downward, project it horizontally, and draw the step number 6. So in a second scenario, the flow of solution is going to be like this one. Okay, so in both cases we are going to follow a zigzag path, whether you are starting with front view or starting with top view. So out of those two scenarios, any scenario could be applicable to given example. Okay, now let's look at this question. A rectangular plane, 30 by 60 mm dimensions, shorter side is in HP. So here the shorter side is in HP. So this is going to be our resting reference. What is resting reference? This shorter side, if I consider this as rectangle ABCD, then this is the side AD that I am going to consider as a resting reference. Okay, next, and 30-degree inclined to VP, draw its projections when plane is inclined at 45-degree to HP. Now there are two inclination, this 45-degree inclination to HP and 30-degree inclination to VP. Now out of those two inclinations, I need to differentiate which one is surface inclination and which one is other inclination. So if you look at this statement, plane is 45-degree inclined to HP. So whenever surface inclination is given, this wording could be surface of the plane or surface of that object incline. They can simply say a plane incline, even they can say lamina incline. All these are going to okay, in addition to this one, in certain examples they call it plate also. So if any of these is there in a question statement, all these are going to indicate the surface inclination. So this 45-degree is inclination of the surface, 45-degree with HP, and second inclination, as we mentioned earlier, the surface inclination and other inclination. This other inclination is going to be in the form of any of these. It could be side, edge, axis, diameter, diagonal, or any new feature also may come in a picture that we'll get to know while solving examples. Now, for this specific example, what is the other inclination? The shorter side on HP is 30-degree inclined to VP. So, for this example, the other inclination is given in the form of side. So, now when you are going to solve the solution, this is the surface inclination that you are going to consider in a step number 2, and this is the inclination that you are going to consider in a step number 3. Okay, I hope you have got now how to proceed with the solution. Okay, so let's come to this scenario now. Now let's see whether we are going to follow scenario A or scenario B. The rectangular plane resting on shorter side in HP, surface is inclined to HP and side is inclined to VP. Now when you have got the surface inclination is with HP. To draw basic view, as I mentioned earlier, what we need to do, reduce that surface inclination to 0. Surface is inclined to HP. When you reduce that inclination to 0, it will become parallel to HP. And when you make that plane parallel to HP, its true shape is going to be visible in a view that you are going to get in HP. If plane is parallel to HP, in HP you will get true dimensions. If plane is parallel to VP, in VP you will get true dimensions. So this object is inclined to HP, that you have made parallel to HP. So its true shape is going to be visible in HP. So the solution is going to start with a view that you obtain in HP. And we know that in VP you get front view and in HP you get a top view. So now the solution is going to follow this scenario A, because we are going to get true shape in HP, that is in a top view. So solution is going to start with the top. Okay, so now we are going to follow this scenario A. If that plane is inclined to vertical plane, you will have to make it parallel to vertical plane and you will get its true shape in a vertical plane, that is in front view. So in that case you will be referring to this scenario B. But for this example, the scenario that we are going to refer is A. So let's draw a solution now. So let's say this is XY line. Solution is going to start with the top view, where we are going to get the true dimensions of the plane. So this is a rectangle, this dimension is 30, this dimension is 60. Now while drawing this rectangle, why I am not drawing rectangle like this one, this dimension 30 and this dimension 60? Because in a basic view what we have written additionally, we have made surface parallel to the plane. Additionally, identify the resting reference, keep it at left and perpendicular to XY. Identify the resting reference, keep it at left and perpendicular to XY. So we know that this shorter side is my resting reference, so that I have to keep at the left. So I have kept it at the left. Additionally, it has to be perpendicular to XY. So for that reason, this is the only choice available to draw this top view. Let's say this is A, B, C, D. Now project all the points for the front view. Now the plane was resting on one of its side in HP. If that side is in HP, it means its front view is going to be located on XY line. We have made it parallel to HP, so now it is completely resting in HP, and for that reason its whole front view is going to be located on XY line itself. So this is A dash, B dash, C dash and D dash. So this is our basic view. Now step number 2, we are going to consider the surface inclination. Third one, we are going to consider other inclination. Surface inclination, the surface is inclined to HP at an angle of 45 degree. Let me check it once again whether it is 45 only or something else. Yes, 45 degree inclined to HP and side is 30 degree inclined to VP. So by keeping some random distance, first locate A dash, D dash. This point must remain on XY line, because question statement says that this side is in HP. If it is to be kept in HP, it means its front view should remain on XY line always. So at some random distance from this front view, locate the A dash, D dash first. Draw a line which is inclined at 45 degree, because that is the surface inclination. Now as I mentioned, when you have drawn view number 2, that is we started with the front view, we got the view number 2, now we are going to draw view number 3. So we are going to just provide the rotation, or we are just going to change its orientation. The dimensions and shape is going to remain same. So take a distance of A dash, D dash to B dash, C dash in a compass. Keep compass at AD dash and draw an arc and locate the B dash and C dash. So this is going to be second front view. Now once you have got that second front view, to draw the step number 4, project points from this front view, project points from the first top view, connect the respective points and complete the view. So this is A, B, C or D. This was the front view, step number 2. The step number 3 is also front view, but the dimensions of those two are same, so nomenclature is same, A dash, D dash, A dash, D dash. But this is top view, this is also top view, but if you compare the dimensions of those two are going to be different, so same nomenclature cannot be there. So nomenclature for the second top view will become A1, B1, C1, D1. So now this is our second top view. This is step number 4. Now we are going to draw step number 5, and we know that we are just going to rotate the view without changing its dimensions. This inclination in a step number 3 was inclination with HP. Step number 5 is going to be inclination with VP. Now what is inclination with VP? The side is 30 degree inclined to VP. So randomly so at some point from this XY line, draw one line which is inclined at 30 degree. Now this resting reference A1 D1, or this side which is resting in HP, this side is to be made inclined to VP at an angle of 30 degree. So I have drawn that line 30 degree incline, and by keeping some random distance from XY line, I'll locate the first point A1. I'll take distance from A1 to D1 in a compass and locate this point D1. So this is our A1 D1 line. Similarly, locate the point Just remember that the relation or shape size dimensions of those two views, step number 4 and step number 5, should be exactly identical. Now, as I am drawing it in the form of freehand sketch, so those two views are appearing different, but ideally those two are going to be exactly same. The length of a1d1 must be equal to length of a1d1, length of a1b1 must be equal to length of a1b1, and if angles between AD two adjacent sides are 90 degree, then same angle has to be replicated in the step number 5 also. Now the final view, project all the points vertically upward. Take the projections from this first front view. Now connect the respective points. So projector of A from the top view, projector of A from the second front view. This is A1 dash. Nomenclature is changing because this front view and this front view, those two are going to be different from each other. So this time we need to change the nomenclature. So this will be A1 dash. Projector of B, projector of B. So this is B1 dash. Similarly, this is C1 dash, and this is going to be D1 dash. Now connect the points in a proper sequence and complete the view. So this is our final front view. So this is final front view and this is final top view. That is the those two are the views of the object in a final condition, but to reach these dimensions we need to go through the step number 1 and step number 2. Okay, and finally provide the dimensions, whichever dimensions are given in the question. All dimensions should be shown on the sketch also. Okay, so this is the solution. I hope you understood everything.